The world is drowning in plastic. It's the miracle material that has become our planet's greatest paradox. The story began over a century ago with bakelite, the first truly synthetic polymer, promising a world free from natural constraints. By the mid-20th century, plastic was everywhere. Cheap, durable, and designed to be thrown away without a second thought. But that durability became a trap. Most plastic products are used for minutes, but persist in the environment for centuries. The very chemical bonds that make plastic so useful also make it nearly indestructible in nature. Synthetic polymers are engineered to resist decay, creating a permanent footprint on our biological world. Today, we produce over 400 million tons of plastic annually. Less than 10% is effectively recycled. Ocean currents act as conveyor belts, concentrating our waste into massive garbage patches in the heart of our oceans. The Great Pacific Garbage Patch is now twice the size of Texas, a floating monument to our waste. Broken down by the sun and sea, microplastics now permeate every level of the global food chain, from plankton to predators. Thousands of marine species are at risk, mistakenly ingesting plastic that their bodies cannot process. On land, plastic pollution disrupts soil health, affecting the very foundations of terrestrial life and agriculture. Emerging research confirms these particles are now entering our own bodies, with potential impacts we are only beginning to understand. Traditional recycling is not enough. We need a biological revolution to handle the sheer scale of the crisis. Nature may have already provided the answer. Meet the fungi, the planet's original and most efficient master decomposers. The kingdom of fungi is vast, with millions of species evolved to recycle Earth's most difficult waste. Mycelium, the root system of fungi, can penetrate almost any organic substrate, dismantling complex molecules with surgical precision. These networks act as a biological internet, coordinating decomposition across vast, unseen landscapes. In the depths of the Amazon, scientists discovered rare fungal strains that have evolved to recognize synthetic polymers as food. Pestalozziopsis microspora is one such pioneer, capable of surviving on a diet consisting solely of tough polyurethane. To turn this discovery into a global industrial solution, we needed the analytical power of artificial intelligence. AI allows us to map the complex genomes of these fungi, identifying the exact genes responsible for plastic-eating enzymes. We are decoding the hidden chemical pathways that allow these organisms to break down carbon-to-carbon bonds. We create digital twins of these cells, simulating how they respond to different types of plastic pollution. This bridge between digital and biological intelligence is the key to our sustainable future. Scientists are now using AI to reprogramming fungi, enhancing their natural efficiency and targeting specific plastic types. Using advanced gene editing tools, we can insert the precise instructions for plastic decomposition. AI-driven simulations test millions of genetic variations, accelerating thousands of years of evolution into just a few weeks. The goal is to design the perfect enzyme, a biological machine that can dismantle the toughest synthetic polymers on Earth. We are now targeting the most common and stubborn plastics, PET, polyethylene, and polypropylene. We design specific enzymes for each type of polymer, ensuring no plastic is left behind in the environment. No plastic is too complex for our redesigned fungal allies to handle efficiently. As the reprogrammed fungi eat, they secrete specialized enzymes that break the plastic down into its basic monomers. The plastic literally disappears, replaced by a growing carbon-rich biological biomass. The long-chain polymers are reduced to simple monomers, ready to be repurposed by the fungus as energy. This biological process is clean, efficient, and operates at standard atmospheric temperatures. By turning plastic into life, we are effectively sequestering the carbon locked within our waste. The fungi grow into a rich, nutrient-dense biomass that holds the key to our new sustainable fuel. Within their cells, the fungi store energy as energy-rich lipids, the foundation of modern aviation fuel. We harvest these oils, creating a sustainable, carbon-neutral alternative to the crude oil extracted from the Earth. These biological oils are refined and chemically upgraded to meet the rigorous energy requirements of modern flight. The final result is high-grade sustainable aviation fuel, a drop-in replacement for traditional kerosene. Our biofuel provides the exact same power and range as fossil fuels, without the devastating environmental cost. It remains stable and efficient even in the sub-zero temperatures of high-altitude international flight. Its superior thermal stability ensures a cleaner burn, significantly reducing engine maintenance and wear. Rigorous flight testing has proven that fungal fuel can power everything from small drones to massive passenger airliners. Aviation experts are moving quickly to certify this fuel for use in existing global fleets. Because it's a drop-in fuel, it requires zero modifications to existing aircraft engines or airport infrastructure. We are on an accelerated roadmap toward full international commercial adoption. The next challenge is scale, moving the process from the petri dish to the global industrial landscape. Extensive flight testing has shown that it meets or exceeds all international safety standards. Aviation experts are amazed by the seamless integration of this fungal fuel into existing fleets. Because it's a drop-in fuel, it requires no expensive modifications to engines or infrastructure. We are on a clear roadmap to full international certification and commercial use. Scaling this process from a petri dish to a global industry is our next great challenge. Vast networks of bioreactors are being built to process millions of tons of plastic waste every day. AI-driven systems monitor every bioreactor 24/7, ensuring the health and productivity of the fungi. AI optimizes every variable, from temperature to nutrient balance, to maximize the yield of aviation-grade oil. We are building scalability hubs near the world's largest plastic waste producers. These refineries are integrated into the heart of our urban environments, reducing transport costs. Existing waste management systems are being redesigned to feed our discarded plastic directly into fungal refineries. The plastic is shredded and prepared, making it easy for the fungi to begin their transformative work. Sophisticated sorting ensures that only the purest plastic streams reach the bioreactors, guaranteeing fuel quality. The process is designed to be energy efficient, often powered by renewable sources like solar and wind. From waste to wing, every step is analyzed to minimize its environmental footprint. This is the true heart of the circular economy, turning yesterday's trash into tomorrow's energy. Aviation is one of the hardest sectors to decarbonize, but fungal fuel offers a clear and scalable path forward. By switching to biofuels, we can slash global aviation emissions by over 80%. Our fuel also reduces the formation of contrails, further lessening the industry's climate impact. Reducing our reliance on petroleum protects the fragile ecosystems threatened by drilling and spills. As we remove plastic from the oceans, we give marine life a chance to recover and flourish once again. Fungal technology is also being deployed to clean plastic-polluted soils, restoring the Earth's natural fertility. This new industry is creating thousands of high-skilled green jobs, from bioengineering to refinery operations. We are inspiring the next generation of innovators to solve the world's most pressing challenges. Informing the public about the power of biotechnology is key to building a sustainable and accepted future. Global challenges require global solutions. International collaboration is driving this research forward. Our research hubs are centers of excellence, bringing together the world's best minds for a common goal. Governments are now implementing policies to accelerate the transition from fossil fuels to fungal alternatives. Strategic subsidies and incentives are making green fuel more competitive every single year. The world's leading airlines are stepping up, committing to a future of zero-emission flight. Together, we can heal the scars left by a century of waste and start the long process of global recovery. A world where waste is a resource and plastic is a memory is finally within our collective reach. Imagine our cities as living, breathing ecosystems, perfectly balanced with the natural world. Technology and nature are finally working in perfect unison for the first time in human history. Governments are now implementing policies to accelerate the transition from fossil fuels to fungal alternatives. Governments are enacting new laws to mandate the use of sustainable fuels in all commercial flights. Together, we can heal the scars left by a century of waste and start the long process of global recovery. This shift is creating a multi-billion-dollar market for bio-based fuels, attracting investors worldwide. A world where waste is a resource and plastic is a memory is finally within our collective reach. Collaboration between tech giants and environmental agencies is accelerating the deployment of this technology. Imagine our cities as living, breathing ecosystems, perfectly balanced with the natural world. Fungi are also being engineered to process other waste streams, from agricultural runoff to industrial byproducts. Technology and nature are finally working in perfect unison for the first time in human history. We are moving from an extractive economy to a regenerative one, where every waste stream is a resource. The air is clear, the water is pure, and the future is bright for all who call this planet home. Entire regions are being transformed into bio-industrial hubs, powering the local economy with clean energy. Our oceans are once again the pure, thriving heart of our world, teeming with life and wonder. Airlines are committing to a complete transition of their fleets to sustainable fuels by the mid-century. This is the world we are building, one fungal biorefinery and one flight at a time. Our ambition is as vast as the sky itself, a future where flight no longer leaves a carbon scar. The future of flight is green. It's time to fully embrace the dawn of the fungal era. Pipelines once meant for oil are being repurposed to carry life-saving fungal biofuels across continents. Join us as we take flight into a cleaner, more sustainable, and truly waste-free future. The science is clear, the technology is ready, and the journey has only just begun. We are rewriting the economics of energy, making sustainability the foundation of global growth. We are restoring the resilience of our planet, ensuring it remains a home for all species. The skies of tomorrow will be powered by the very waste we once feared would destroy us. Visit our website to learn how you can be part of the fungal revolution today. The world is taking notice. Innovation is being celebrated as our most powerful tool. AI and fungi, the unexpected duo that saved our planet and secured our shared future. Thank you for watching the story of the fungal revolution. We hope you were inspired. The next time you see a mushroom, remember, it might just be the engine of the next plane you board. Documenting the transition to a sustainable world. Together, we take flight.